We're continuing with section 5.3. This is part 2. Use the multiplication rule for independent events. Studies have shown that about 90% of the world population is right-handed. If 3 people are randomly selected, find the indicated probabilities below, okay? So first, what have they told us? They've told us that the probability of, I'm just going to put a capital R for right-handed. If 90% of the world is right-handed, the probability would be 0.90, or 0.9 even you could use, but we'll do 0.90. So the probability that a person is not right-handed would be what? 1 minus 0.90 or 0.10, or 10% of the population is not right-handed. Okay, we're supposed to find the probability if we select 3 people are randomly selected. Again, we're talking about the entire world population. So in the event that we're taking such a small sample like 3 out of the entire world population, we can assume that this is done with replacement, even though it may not be. But let's just assume we're going to do this with replacement. In other words, remember, with replacement means independent. That's what that means. With replacement, independent. Okay? So, think about the balls in the urn. If you put it back, each time you take a ball out, it's just like it was the first time you took one out. Okay, probability that all 3 are right-handed. So let's write that. Probability of right-handed and right-handed and right-handed, all 3, would be equal to, and again, as I've been saying, we don't have to write that. If it's independent, where the probability is not changing each time, so instead of writing 3.90s, I can just raise it to the 3rd power and get 0.729. Now let's find the probability that at least one of these 3 people is right-handed. Probability of at least one of the 3 is, here's my capital R, meaning right-handed. Well, the probability of at least one is equal to 1 minus the probability of none. 1 minus the probability that none of the 3 is right-handed. So here's where it comes into play that we wanted to know what the probability of being not right-handed equals. So 1 minus, I'm going to use a bracket here to make this really clear, 3 people not being right-handed. So that would be 0.10. The first one is not right-handed, and the second one, and the third one. But those probabilities are all the same, so I'm not going to write it 3 times. I'll raise it to the 3rd power. 1 minus 0.10 to the 3rd power equals 0.999. Okay, so if it's a 90% chance that a person's right-handed and you select 3 people out of the population, the chance that you get at least one person who's right-handed is really high. But that should make sense because it's a really high probability in general. Okay, what about the probability that we select 3 people and the first 2 are right-handed, but the 3rd one is not? Well, let's write that. Just like we've been doing, if you'll use some words first, or at least some kind of symbols with the English language first, then you can go to math. It's a lot easier. Right, the first one is right-handed, and the second one is right-handed, and the 3rd person is not right. See, it's going to be so obvious what I need to do now because I took the time to write this out. Probability of right-handed, we said, was 0.90. And means multiply. Second person's right-handed, 0.90. And means multiply. Third person, not right-handed, 0.10. So it just comes straight from the little abbreviations I've written here. It's really clear what I need to do. And when you multiply those, you get 0.081. Would it be unusual for all 3 randomly selected people to not be right-handed? Okay, would that be unusual that you select 3 and none of them are right-handed? Well, let's find that probability. The probability of not right-handed, the first person, and the second person is not right-handed, and the third person is not right-handed. Okay, well, what's the probability of not right-handed? See, we wrote it here. It's all just real easy to do because you've got it all written down. 0.10, and we're going to multiply that 3 times. So again, I could write it 3 times or just do this. Raise it to the 3rd power. What do we get? That is 0.001. So would that be unusual? They didn't ask me the probability, but if I don't have the probability, I can't answer the question. So they didn't say find the probability, they just said, is that unusual? Well, I need the probability because my criteria is any event that has a probability less than or equal to 5% or 0.05 is unusual. So I need a number to compare to that. So my answer would be yes, because, here I'm going to explain, 0.001 is less than 0.05, our cutoff for, excuse me, for unusual events.